Hi guys, so today we are going to learn on Form 5 and Maths Chapter 1, Circular Measure. So, from the title of this chapter, right, you know already. Today you're going to learn what is circle. So basically, circle, right, this topic is very easy. Okay, in Form 5, this chapter is very easy because you are going to learn for 2 formulas only. And this chapter, right, you have learned a bit in Form 2, okay, in Form 2 syllabus. So we have to know that what is the shape of circle first. So the shape of circle, right, is like this. Okay, circle. Okay, I hope everyone knows it. Okay, so circle, every single circle, right, they have their respective centers. This center, right, we normally call it as origin, okay, origin or center. So it has 2 names, either origin or center, and we normally use symbol O, okay, the letter O to represent center of circle. So this one is the first part of the circle, and second part you have to know the outermost line of circle, which means the perimeter lah. Okay, the perimeter of the circle is known as circumference. Okay, so circumference is really the perimeter of the outermost line of circle. But I prefer to write perimeter lah. Okay, now for the third part, you have to know what is radius, what is diameter. So radius, right, is actually a line, okay, a straight line that connects from the center of circle towards the circumference of circle. Okay, this line is known as radius. Okay, radius. I have to label it using purple color. Okay, so you know already what is radius. So now, what about diameter? So diameter is actually, right, a line, a straight line that connects both ends of circumference and touches the center of circle. So basically the line is like this, yeah. Okay, so this blue line, right, okay, this blue line known as diameter. Why? Because you see, both ends of the line touches the circumference of the circle, and it also touching the center of circle. So this line, right, is known as diameter. So the difference between radius and diameter, right, is actually radius, right, is the line that touches one end of the circumference, and diameter is the line that touches both ends of the circumference. Okay, this is the difference, and you have to know that radius is equals to half of diameter. Okay, radius equals to half of diameter, or you can write like this: diameter equals to double of the radius. Okay. And now we have to proceed to another part of circle. So also a shape of circle and the center. Radius. Now let's say the radius is like this. Okay, I draw 2 radius for you. Okay, 2 radius for you. One radius is like this, another is like this. So after I draw these 2 radius out, right, you can see that the circle now is being divided into 2 different parts. Okay, so which means part 1 and part 2. So you can see that both parts, right, have the different sizes. So you can see P1, which means part 1, right, it has smaller size, whereas for part 2 it has bigger size. So for the smaller size, this section we call it as a minor sector, whereas for the bigger size we call it as major sector. Okay, so minor and major. Minor, which means smaller, major, which means bigger. Okay, now we have minor sector, right? So how about, so now you can see here the circumference also being divided into 2 different parts. So the first part is the part that I shaded with green color. Okay, this part, and also the smaller part I shaded using brown brown color. Okay, so the green color is longer, right? So this line we call it as sorry, I have to use green color. Green color. Okay, now this line, right, is known as major. Okay, it is also major because it is longer. Okay, longer in size. So what is arc? Is actually the curved part of the circle. It is known as arc. Okay, so this one is the basic components of circle, and you have to learn one more components, yeah? Okay, very famous in this chapter. Okay, let's say I draw another circle for you. Okay, I also draw you a center. No need lah. Okay, let's say I draw a chord for you. Okay, this line is known as chord because it didn't touch the center, right? So this line is known as chord. How about the region that is bounded by the chord and the arc? So basically, right, this region I say just now is over here. Okay, the region that I shaded using red color. Okay, so this region, right, is known as segment. Okay, segment. So you have to know segment always related to chord and also the arc. Okay, segment always related to chord and the arc. Okay, so this is known as a segment. So basically, right, these are the basic components of a circle that you have to know in this chapter before you can do all the questions in chapter 1. Okay, so now let us move on to next part. So next part, right, we have angle with different units. What is the meaning? So basically, right, in lower form, okay, since lower form or since primary school, you know that angle, we measure it in degrees, right? Like for example, 30 degree, okay, 30 degree, okay. The symbol here is known as degree lah, okay, which means this angle is in degree unit. But now you have to learn one more unit, is known as radians. Okay, I try to write all the units for you lah. So basically for angle, you have 2 units. Okay, the first one is degree, and also radian. Okay, radian, R-A-D, rad. So we normally shortcut lah. Okay, shortcut we call it as rad. Okay, rad. So how can we convert the angles from degree units to radian units lah? So for example, I give you 30 degree. So if the questions give you 30 degree and ask you to convert it from degree units to radian units, so basically, right, from degree, okay, I draw a flow chart for you. Let's say you have degree and radian, okay, 2 units for angle. So every single time when you want to convert degree to radian, right, okay, from degree to radian, you have to times pi over 180. Okay, on the other hand, if you want to convert radian to degree, okay, radian to degree, right, you have to times 180 over pi. Okay, 180 degree over pi. So some of the students will ask me, what is the value of pi? Should I use 22 over 7 or 3.142? So in MX, right, we do not use 22 over 7. Okay, we didn't use 22 over 7. We only use 3.142 as the value of pi. Okay, remember, we do not use 22 over 7 in any question unless the question states clearly that it wants you to use 22 over 7 as the value of pi. Okay, so if not, just use 3.142. Okay, if the question didn't mention any value, right, which means you have to use pi equals to 3.142. Cannot use 22 over 7 unless the question states clearly. Okay, so for example, let's say I have 30 degree over here and I want you to convert it from degree units to radian units. So actually 30 degree, right, if I want to convert degree to radian, I have to times it with pi over 180, right? So 30 degree times pi over 180. So 30 degree equals to, okay, now substitute the value of pi. So actually pi equals to 3.142 over 180 degree. So 30 degree, okay, you just press the calculator. 30 times 3.142 over 180. You get, okay, now you will get a long number, right, with so many decimal. So in maths, you have a rule to follow, okay, which means 2 decimal places plus 4 significant figures. So which means you have to fulfill these two conditions so that your answer is correct when your answer is a long decimal. Okay, so in this situation, right, we have the calculator one 0.523666666667, right? So we have to follow this rule, because if we didn't follow this rule, right, you will get no marks for your answer. So this is the golden rule in MS lah. Okay, 2 decimal places plus 4 significant figures. Okay, so now 2 decimal places. So we have 1, 2. Okay, is it enough? Did I fulfill the conditions? No, right? Because I still have one more conditions to be fulfilled, which is the 4 significant figures. So what is 4 significant figures? If you forget it, please go and revise back Form 3 Mathematics. I think, if I'm not mistaken, it's under Form 3 Mathematics Chapter 2. Okay, Chapter 2. Okay, so 4 significant figures from here, I can straight away know that my answer should be equals to 0.5237. Okay, 37. You have to round off. 37. So remember to write RAD right. Okay, so actually 30 degrees equals to 0.5237. Okay, how about when I ask you to convert 2 pi rad? Okay, 2 pi rad. So 2 pi rad equals to how many degrees? So when you want to convert from radians to degree, right, we have to times 180 over pi. So 2 pi rad equals to 2 pi times 100 over 80 over pi. So pi can be simplified, right? So you will eventually get 2 times 180 and equals to 360 degrees. Okay, so another case, let's say I want you to convert 2.147 rad to degree. How to convert? So if you want to convert radians to degree, you have to times 180 over pi. So 2.147 times 180 degree over pi. Okay, over pi, yeah. So substitute the value of pi, 3.142. So now you just straight away press the calculator to get the answer. So 122 point. Okay, now these situations you can just directly round off to 123 degree, because the original answer is like this: 122.9980904. Right? Remember our formula? Our golden rule: 2 decimal places plus 4 significant figures. Let's say we look at 4 significant figures first. Okay, so 4 significant figures, 1, 2, 3, 4. But I want 2 decimal places. So 2 decimal places is calculated from the decimal point, after the decimal point. So 1 decimal places, 2 decimal places. So actually I have to take 122.99, right? But behind the 9, right, it has 8. 8 is the number that exceeds 5. So you have to round off. So after you round off, right, eventually you will get 123 degree lah. Okay, 123 degree. Okay, so this is the conversions from degree to rad and rad to degree. So basically, if you master this, right, then it is not a problem for you to do other questions in this chapter. So now let me introduce you the formula in this chapter. So basically it has 2 formulas only. So the first formula I have to draw for you first. Okay, I have to draw for you. Okay, this is the sector. Okay, a sector. Okay, now we have center O here, and we have also radius here, and also angle here. Right? So the first formula, right, is for finding the arc line. What is arc line? Arc line is the line that I shaded using green color. So arc line, right, the formula for calculating arc line is S equals to R data. Okay, S equals to R data. So what is S? S is actually the arc line, which means the green color part. Radius, right, is actually the line that I shaded using red color. Okay, red color. What is data? Okay, this symbol is read as data, T-H-E-T-A, data. So data, which means angle lah, angle which means the angle subtended at the center. So I highlighted it using yellow color. Okay, so this formula. Okay, what is the special point of this formula? Okay, actually, right, you have to know very be careful. You have to very be careful. Every single time when you use this formula, right, you have to make sure that the data, right, is in radian unit and not in degree unit. This is because this formula, right, is specially created for the angles in radian unit. So what happens when you sub the angle with degree unit? The answer is the arc length you get is incorrect. Okay, it is incorrect. So please be careful that every single time when you use this formula, right, you have to make sure that the angle you sub into it must be in radian units. Okay, this is the requirement of this formula. So if the questions provide you the angles in degree units, please, the first step is to convert the angle with degree units into the angle with radian units so that you will get correct answer for your arc length. Okay, so now this is the first formula, and the second formula, I have to draw another sector for you. So this is the angle. Okay, angle, radius. Okay, now what is the second formula? Is the area of sector. Is area of sector. Area of sector, right, is the region here. Okay, region here. Okay, I try to shade it for you. Okay, the blue region, right, is actually the area of sector. So how to calculate the area of sector? We have to use this formula. Area equals to 1/2 r square data. Okay, area equals to 1/2 r square data. So this formula is also has a special point, which means the data, right? Okay, please be careful. The data you sub into it must in radian unit. Okay, this data must in radian unit. Okay, so after you learn these two formula, right, actually this chapter comes to the end. So we are going to do some exercise lah. So question 1. Find the arc length MN in cm of each of the following sectors MON with center O. So the questions did mention that use pi equals to 3.142. So for these questions A, we want to find arc length, which means this line MN, the line that I shaded using yellow color. So how to find arc length? Use the formula S equals to R data. So first thing first, you have to identify what is the radius and the data. So radius, right, the questions just provide us, which means 12 cm. So we will just substitute it as 12. And then the data, please make sure the data should be in radian unit. So the questions provide it in radian unit. So you can straight away substitute it into the formula. So 12 times 1.1. So you will get 13.20. So SMN. SMN means arc length MN. Okay, arc length MN. Now, next questions. We have to find the arc length as well. So the arc length is over here, MN. So arc length for MN equals to R data. So R is 8 cm, right? So 8, and then make sure the angle is in radian unit. So the question just provides the angle in radian unit. So we can straight away sub it into the formula. 8 times 2, so you will get SMN equals to 60. Okay, unit. Okay, you can choose to write unit or not writing a unit. It is not a mistake for you if you don't put any unit, unless for angle you must put unit. Other like length, volume, area, for this measurement or this quantity, right, you actually don't put unit is also not a mistake. Okay, so next question. Find the radius in cm for sector AOC with center O. And these questions also did mention use pi equals to 3.142. So we need to find the radius. Okay, they provide us the arc length of the sector and also the angle of the angle subtended at the center. So we have to write the information first. So radius is 13.09 and the data provided is 5/6 pi. Okay, 5/6 pi. So how about the pi here? The question asks us to use pi equals to 3.142. So from now we have to substitute the pi with 3.142. Okay, 3.142. So 5/6 times 3.142, you will get 2.618 rad. Okay, 2.618 rad. So now, sorry guys, not radius, it's actually arc length equals to 13.09, sorry. So we know that the arc length of AC is actually equals to 13.09, right? So what is the formula of arc length? Is R data, S equals to R data, right? So R we have to find, so we put it as R, and data is 2.618 equals to 13.09. So radius equals to 13.09 divided by 2.618. So your answer should get 5. Okay, 5. So the radius of the sector is 5. Next, question 3. So the diagram on the right shows a circle with center O. It is given that the major arc length, guys, be careful, yeah? Major arc length. Okay, it did mention clearly major arc length. EF is 25 cm. So which means major is where? Major is the longer, right? Longer is over here. The longer one is over here. Okay, the line that I shaded using yellow color. Okay, this one is the major arc length. So 25 cm, and also angle EOF equals to 1 point. Sorry, I have to use different color. Okay, let's say green color for angle. Angle EOF equals to 1.284 rad. Find the radius of the circle. So the question just now provides us arc length and also the angle, right? But this is the point where a lot of students make mistake. Okay, now the student will straight away write, oh, arc length equals to 25. So radius it as R and data is 1.284. So when you do this step, right, which means you have a wrong concept on circle. So basically, every single time when you want to find radius using the information provided such as arc length and also the angle, you have to make sure that the angle you substitute in should always towards, okay, it is always face towards, okay, face towards the arc length that you substitute into the formula. What is the meaning? For example, let's say this is the sector, okay, a sector, a sector, and the data is over here. Okay, let's say the data is 3 rad, and then the length, right, is 14 cm. Okay, now when you want to find radius, okay, you can straight away sub S equals to 14 R times 3. Okay, why? This is because this angle is facing towards the arc length provided. How about this situation? The length provided is 14 cm, but the angle is over here. Okay, now does this angle facing towards the arc length? No, right? Instead, the angles face towards another side. So you cannot use this angle as the angle in the formula. So how we need to find the angle from for these questions, right? Okay, for these questions, because the angle provided is not facing the arc length provided, which means it is not facing the 25 cm. So we have to find the angle that exactly facing the 25 cm. So what is the positions of that angle? Which means it is over here. it is the angle that's shaded using pink color. Okay, so this pink color angle, right, is actually the angles that face towards the 35 cm. So how can we find the pink color angle? So we know that a complete angle, which means a circular angle, equals to 360 degrees, right? But be careful, yeah? The angle is in radian unit. So 360 degrees also equals to 2 pi rad, right? So now we know that in these complete angles, right, one of the angle is actually, one of the angle is equals to 1.284 rad. How about the remaining angle? The remaining angle. The remaining angle. So how can you find it? You just use 2 pi minus 1.284 is okay. You just done this section. So you have to find the correct angle first. So the correct angle is actually major angle EOF equals to a complete angle is 2 pi, right? 2 pi minus 1.284, so that you can get the pink color angle. Pink color angle. So value of pi, so for these questions, right, it didn't mention clearly, so we just assume that the value of pi is 3.142. Don't use 22/7. Just use 3.142. So you just press the calculator to get the answer. So you will get 5 rad. 5 rad. So basically this angle is 5 rad. But now don't stop here because our objective is to find the radius of a circle. So we know that the arc length of the EF, arc length of EF is 25 cm, right? So the radius times data. Data is 5, so equals to 25. So radius equals to 25 over 5. Radius equals to 5. 5 cm. Now questions B got some error. Got some problem. I write it incorrectly. It is actually minor arc. Minor arc. So question B, it wants us to find the minor arc. What is minor arc? Minor arc is actually the arc over here, the smaller arc. So how can we find the smaller arc? So arc length formula is actually equals to S equals to R data, right? So radius we just now find is 5, right? And the data is how many? Data, you should use the angle that faces the arc length that you want to find. So which means 1.284. So 5 times 1.284, you will get 6.42. Now 6.42, right? It is under 2 decimal places, but is it 4 significant figures? No, right? So we have to replace a 0 after the 2. So you will get 6.420. 6.420, so that you can fulfill the condition 2 decimal places and 4 significant figures. Now next question, the diagram on the right shows semicircle. What is semicircle? Semicircle is actually half of the circle. Like this, this is the complete circle. Semicircle is which means half. So which means you divide the circle into half lah. Let's say you divide the circle into half. Divide the circle into half. So this half of the circle is known as semicircle, because the meaning of semi is equals to 1/2, which means half of the circle. So semicircle is actually half of the circle. So a semicircle OPQR with a radius of 5 cm. So first thing first, you have to label, because the diagram, right, didn't label it for you. So the radius is, let's say the radius is here, or you need to label it at here or here, is not a problem. It is correct. So let's say I label it on the line OQ. So given that the arc length QR is 5.7, arc length QR, Okay, 5.7, it did label it for us. Calculate the value of data in radian. Okay, now, the data, right, the positions of data is over here. But the information, which means the outline provided, is on the other side. Which means, right, the angle that towards the arc length that provided is not the same as the angle that we need to find. So which means we have to find the angle facing the QR so that we can find the value of data. So arc length of QR equals to 5.7. Okay, now radius is 5. Okay, how about the data? Data, please do not assume that the angle over here is the angle that you need to find in A. No, because the questions already label the positions of data. It is over here, not angle QOR. So you cannot assume that angle QOR is the value of data. No, it is incorrect. So we have to find angle of QOR first. So angle of QOR equals to 5.7. So angle of QOR equals to 5.7 over 5. So basically angle QOR equals to 1.140 rad. Okay, 1.140 rad. So now I simplify the diagram for you. Let's say this is the line POR. And then we have a slanted line OQ. Okay, just now we know that angle QOR is 1.140 rad. And data is adjacent to 1.140 rad. So we know that for a complete straight line, right? For a straight line, the total angle is 180 degree. So 180 degree equals to pi. Okay, you have to memorize it. 180 degree equals to equals to pi, and 360 degree equals to 2 pi. These two, right? You have to memorize it so that you can do the questions quickly. Okay, so 180 equals to pi. 360 degree equals to 2 pi. So because in this chapter all the angles used must be in radian unit, so 180 degree equals to pi. So data right equals to pi equals to 1.140, right? So what is the value of pi? So the question did mention, right, pi equals to 3.142. So pi 3.142 minus 1.140. So data equals to 3.142 minus 1.140. You will get 2.002 rad. So this is the answer for A. Let me erase this here. So for question B requires us to find the arc length PQ. So arc length PQ is over here. Let me use another color. Let's say blue color lah. So PQ is the line that I shaded using blue color. So I want to find arc length. Please make sure that the angle is always faces towards the arc length that you want to find. So what is the angle here? So the data over here, right, is 2.002 rad. So B arc length PQ equals to R data. What is the value of R? Radius is actually 5, right? 5 times 2.002. So arc length PQ, you will get 10.01. So this is the answer for arc length PQ. Last questions for this video, yeah. So let us complete it, yeah. So the diagram on the right shows a sector with center O and a radius of 7 cm. cm. Find the angle data in degrees. So guys, be careful. The angle that questions 1 used to find is in degree unit. So when you give the answer in radian unit, which means you will get no marks. Okay, please be careful when doing questions. Okay, now in degree, right? So first thing first, they provide us radius and also arc length information. So arc length PQ is here, 14 cm, radius is 7, so we need to find the degree, right? So arc length PQ equals to 14, so radius is what? Radius is 7, degree is unknown. Okay, so you just put it as a data, so 14, so data equals to 14 over 7 is means 2 rad. Please remember, if you use the formula S equals to R data, the data inside is actually in degree, is in radian unit. So which means the answer you get right must be in radian unit. So because the question wants us to state the angle in degree unit, so we have to convert it. So how to convert that? So actually 2 rad, if you want to convert radian to degree, you have to times 180 over pi. So what is the value of pi? Pi, the question didn't mention, so we just simply use 3.142. So 2 times 180 over 3.142, you will get 114.58 degrees. Okay, so this is the correct answer. Okay, done. Next, we have to find the perimeter of the shaded segment. So segment, right, is actually the region that I highlighted using green color. So what is the perimeter of the shaded segment, which means the line that I shaded with pink color. Okay, here. Okay, so you need to find the total length of the pink color line. So first thing first, how can you find the straight line PQ? How can we find PQ? So if I draw out the diagram, right, you can notice that the shape is actually a triangle, right? So please remember, in this chapter, right, any triangles, right? Okay, if you draw or if you see the questions consist of triangles, right, you know already. You have to use back the formula in Form 4 Chapter 9, Solution of Triangles. So which means you have to master the chapter first before you proceed to do this chapter. So for this triangle, right, the information provided is actually OP, right? OP and OQ are provided because OP and OQ are the same, because they are both radius. So 7 cm, 7 cm. And then the data is 2 rad. So we have this information. And okay, now we want to find the line of PQ. We want to find the line of PQ. So we have to use cosine rule. Okay, cosine rule. So cosine rule is actually PQ square, the opposite lah. The opposite to the angle. Okay, the opposite of the angle. So what is the opposite of the angle? So angle just now is POQ, right? The opposite side of the angle is actually PQ. So PQ square equals to, now equals to what? Equals to the two lengths, okay, the two lengths, how to say, the two adjacent lengths to the angle. So which means the adjacent length, the adjacent length of the angle. So the angle just now is 2 rad, right? So the two adjacent length is actually OP and OQ, right? So OP and OQ, so you just write 7 square, okay, plus 7 square, adjacent length square plus adjacent length square, minus 2 times the product of the two adjacent length. So 7 multiply the cos angle. Angle is 2. Okay, now the angle in cosine rule, okay, cosine rule, sine rule, or any other formula except the two formula here. Okay, only these two formula have to use the angle in radian unit. And other formula, right? Other formula, the angles, right, must be in degree unit, not radian unit. Okay, so these two formula is very special. Okay, these two formula is very special because only these two formula wants you to use the angle in radian unit. But for other formula like cosine rule, sine rule, okay, and the area of triangle 1 over 2 AD sine C, right, that formula, all of the formula require you to state the unit of angle in degree, okay, not in radian. Only the two formula, S equals to R theta and also area equals to 1 over 2 R square theta. These two formula only require you to use the angle in radian unit. And other formula, no need. Okay, just as usual, use degree unit. So cos, what is the degree unit? Degree unit is actually 114.58. So PQ square. So you just like press, okay, now you press PQ square third square, which means 7 square plus 7 square times, 7 square plus 7 square minus 2 times 7 times 7 cos 114.58. So you will get 138.7644116 on the calculator, right? So please don't write this answer. All you need to do is just square it the answer. So you will eventually get 11.78. Okay, 11.78. So just now we know the length of PQ, right, is actually 11.78. So the length of PQ, okay, the arc length PQ, we also know because the questions just provide us, right? So all you need to do is just sum up the length. So perimeter equals to 11.78 plus 14 cm. So this is the perimeter of the shaded segment. Okay, of the shaded segment. So 11.78 times 14, you will get 25.78. Okay, 25.78. So this is the end of part 1 video. So I hope you guys can actually understand this chapter. So if you have some part that you don't understand, you can comment in the comment box, okay, comment box or the comment sections. I don't know the name of the section, okay, you just comment there and I will try to reply you when I'm free. Okay, so this is the end of this video. So if you have any questions, you just let me know, and if you can, please subscribe and like and share this video to your friends, okay, who have trouble on Form 5 Chapter 1. So see you in the next video. Bye.